Today, India's first solar thermal power plant is ready to generate its first load of energy. Dark clouds looming on the horizon are casting a shadow on this day.
We're just preparing for startup. So everything has to be in order before we can actually start up.
But nothing seems to be going as per the plan. The alignment of the shaft for the turbine seems to have taken longer than anticipated.
There's a minor change in the dimensions of the shaft because it's a 25-meter long thing, and you have to achieve the tolerance of around 0.03 mm.
Until today, the team has remained ahead of time. But now, time is ticking away. And the team is struggling to keep up.
Final alignment check is happening, and then we have to connect the coupling. We are delayed by around 12 hours.
Can this mega structure prove itself in the face of adversity? Is the plant truly ready to create a milestone in Indian history? Mid-April, in Rajasthan, almost 190 kilometers from Jodhpur, the temperature soars well above 48 degrees, and the blowing sand forces the local residents to stay behind closed doors. But for the 1,500-strong workforce of Godavari Green Energy Limited, it is the perfect day to be out, because this is the weather that will transform these 400 acres of barren land into a sea of abundant energy. It is in these harsh conditions that these 4 solar fields spread over an area large enough to accommodate nearly 300 football fields will produce 50 megawatts of electricity every day. When fully operational, the plant will generate approximately 130 million kilowatt hours of electricity in a year. This is enough to meet the energy needs of around 150,000 Indians. To do that, it must first qualify for entry to the national grid. At the helm of this mega dream stands the man with a bold vision and a strong resolve. He is Mr. J.P. Tiwari, CEO and Director, Godavari Green Energy Limited.
As soon as we landed on this site, we knew that this is a completely altogether different kind of land where we have to work. We had no experience on working on desert lands. It was quite difficult to demarcate the land where we have to actually start the work with. We often lost track. We had to identify the corners of the plot, and then the local Desi jugaads were used to mark the places with red flags, and that was how we started the job here.
It was on these 400 acres of barren land that the first step in a long and difficult journey was taken. The foundation for this mega structure was laid a few kilometers away from the small village of Nok, an area in India that receives some of the highest DNI, which is radiation received from the sun, as per the data from NASA and the Indian Meteorological Department.
We started with just the coordinates of this land and an idea that could power the nation sustainably.
The nation's population is well over 1 billion, and the energy needs of this burgeoning mass of humanity are soaring continuously. Today, India burns almost 700 million tons of coal every year, making our coal consumption the 3rd highest in the world. As a result, India releases close to 1.9 million kilotons of carbon dioxide every year. As of today, emissions from coal-fired power plants have caused nearly 1,15,000 premature deaths. Despite the high cost, almost 290 million Indians still live in the dark. It is estimated that by 2030, our carbon dioxide emissions from energy consumption will double, and more than 40% of our energy needs will depend on imports of fuel. Today, only 31% of our energy comes without fatal side effects. It is time we stop digging for answers in the bowels of the earth. We must stop exploiting the earth's fast-dying resources and harvest instead a source of clean, free and infinite energy. One that has been benevolently blessing us with life all this time. The sun.
ओम योगिने नमः, ओम संयुक्ताय नमः, ओम प्रकाशकाय नमः, ओम प्राप्ताय नमः, ओम प्रप्राणाय नमः, ओम। सूर्य एक ऐसा पुंज है, उसके बिना जीवन, किसी भी प्रकार का जीवन, चाहे पेड़ पौधे हैं, ये भी पनपते नहीं, उसके बिना नहीं होते, क्योंकि जो वीर्य और तेज है वो इसी से प्राप्त होता है। क्योंकि जो ग्रह, अपन जिस ग्रह पर रहते हैं, पृथ्वी ग्रह है और सूर्य के ही ये उपग्रह हैं, तो इन पर जो भी जीव जंतु पेड़ पौधे रहते हैं, उनको ऊर्जा जो मिलती है वो सूर्य से मिलती है, ऊर्जा सूर्य से मिलती है। और ऊर्जा अगर सूर्य से सही नहीं मिलती हो तो उसका विस्तार नहीं होता है, विकास भी नहीं होता है। इसलिए अपने धर्म में सबसे बड़ा सूर्य को माना है।
Harnessing the sun's potential is the need of the hour. It is our only chance to preserve this good green earth for our future generations.
Renewable energy is vital, not only for India but for the world itself. For this, the world has now woken up that let us use the energy that God has given us.
With this aim, the Government of India launched the Jawaharlal Nehru National Solar Mission in the year 2010.
Jawaharlal Nehru mission has 20,000 megawatts to be produced by 2022, out of which the first phase, which has to end this year, it is going to be 1,300 megawatts.
500 megawatts of this power will come from a technology never tried before in India. Concentrated solar power, or CSP, also known as solar thermal technology. Concentrated solar power doesn't create electricity directly from sunlight. Instead, it captures and concentrates the rays of the sun to create heat, which is then used to generate power. With the vision of a sustainable future, Godavari Green Energy Limited set out to be the first of the 7 companies chosen under the Jawaharlal Nehru National Solar Mission to set up a solar thermal power plant in India. Godavari Green Energy Limited is a subsidiary of Godavari Power and Ispat Limited and is part of the Hira Group of Industries.
We understand the potential of green energy, not only in terms of environment, but also in terms of the economy also.
With single-minded determination, the company broke ground on the ambitious project in November 2011.
The land was acquired, financial closure done, and the next step was finding a good technology partner who can make this project a success. And then we roped in Abilene-based technology partner named Lauren Engineers.
The endless opportunities of this land soon became apparent. However, nobody in India had the requisite experience and expertise needed to set up a solar thermal power plant of this magnitude. With the experience of building a solar thermal power plant in the USA, the team behind Nevada's Solar One, Lauren Engineers, were the perfect fit for the job.
My name is Steve Doyle. I'm from the U.S. I am the Chief Construction Manager.
The first and immediate challenge that lay before Steve was the foundation of the plant's lifeline, its 4 massive solar fields. These solar fields will have to endure a temperature that varies from -2.5 to well over 50 degrees Celsius in a year, and wind that often blows at a speed of 50 kilometers per hour. The first step in the construction of the solar fields was the installation of 6,000 pylons.
This is one of the pylons that's fabricated, and then it's hot dip galvanized for corrosion protection. It should last for 25 to 30 years. This is a German design, and it has some minimal tolerances that we had to go out to fabrication shops and see if they was able to fabricate these parts for the frames, the pylons, and the cantilever arms. It was a very difficult task.
The workforce took up the daunting task of installing these pylons in 240 rows. Once the pylons were erected, the crew began to assemble and install the 5,760 frames for the parabolic mirrors. Each day, the crew strived to meet their deadlines and assemble an average of 40 frames a day. This task would have been challenging for a trained team of professionals. But for the untrained laborers of Rajasthan, it threatened to be nearly impossible.
One of the hardest problems to start this project, we had a training process. I had to train all the people that worked on this project. Most of the people are local people. All they've done all their life is farm. We have took time to teach them special duty, a task that they perform. They have turned out very good work. The language was a problem, but we placed supervisors who could speak English and Hindi. So it takes 25 to 40 minutes to do both sides.
Yes, sir.
Then you pick it up and you set it on the stand.
And then our turning unit will
The
come.
turning unit will come down.
It grabs and it rotates.
Under the supervision of Hindi-speaking supervisors and Steve's guidance, the ingenious labor force proved to be quick learners.
One Indian word that I've learned in a year, over a year, is TK, okay.
Okay.
Once the frames have been declared TK, they undergo photogrammetric testing. A high-definition camera clicks 38 photographs of the frame. Its software automatically verifies the dimensions of the trough to ensure that it will accurately concentrate the rays of the sun onto the receiver tube. After this process, the frames will be ready for the most delicate and expensive component of the plant, the parabolic solar mirrors.
We had these mirrors from Flabeg. Flabeg has manufacturing units both in the US and Germany, and in fact some of the mirrors came from Germany and some from the US.
These cutting-edge $75 a piece mirrors have to be fitted onto each frame separately.
Mirror has to be as clean as possible. You need to reflect as much radiation as possible into these receiver tubes that act as thermal storage or thermal absorber. If there's a dirt on this, you have interference and the radiation going back to the absorber would be less. So you would be actually generating less or actually tapping less power from sun than what is expected out of this.
Every frame holds 28 mirrors, creating one solar collector element. These mirrors are made of white glass and are extremely thin and clear, unlike regular glass, which has a green tint due to the presence of iron. Coated with silver, one of the most reflective substances known to man, the solar collectors reflect more sunlight than normal mirrors. By the end of the construction, the plant will have 5,760 solar collector elements, or SCEs, installed in rows. The length of each row is the same as that of 4 massive Boeing 747s lined back to back. The team had only 6 months to finish installing all the solar collector elements, which was no easy feat due to their very delicate nature.
There are some limitations. Just like these mirrors are so delicate, we have to run the vehicle at around 5 to 10 kilometers per hour. 12-hour shift, we are erecting around 25 to 30 panels. This is race against time, and we are trying to achieve it.
At the peak of construction on the site, thousands of workers were working hard to stay on schedule until they hit a roadblock. 7,835 mirrors had reached the plant in shatters. These mirrors were part of a consignment that had traveled a distance of almost 12,000 kilometers. With only a few months left for the plant to be commissioned, several rows of solar collecting elements remained to be installed. The 7,835 mirrors from one of the consignments, which had traversed a distance of over 12,000 kilometers, had reached the plant in shatters. These mirrors reflected their dreams, and as their shards lay scattered in the dust, it seemed a crack had appeared in their plans. With only a few weeks left for the plant to be commissioned, several rows of solar collecting elements remained to be installed.
These mirrors were insured. We got it replaced. It took us around 2 months to get them back from Germany. And we still feel that even though we have lost 2 months, we would be able to make it up in good time.